Okay, so let's get started with C. I was around here and uh, let me just, and I want to move session LP from session A to NP. No? Okay, whatever. Let's say we have NP session PC. Okay. So I was exactly like, okay, so I had figured it out that let me go open paint. So this is focus. Yeah, okay. So it was like in the radix sort algorithm. Okay, it defines the end, which is like the source pointer plus the max. So let me just make this for you. Right, so you can see that we zoom in. So see, we have this array, right? We have this array, and say I want to delete the 2. Okay, so I want to delete 2. Say let me just write 1, 2, 3. Right. Okay. Now when I want to delete 2, I will pass this index, which is like 0, 1, 2. So I pass 1. Now source pointer starts here at 1 and the end currently is at 3, right? So the source end here end is our that end of the radix map, right? This end is within the radix sort function, and this end is for the radix map itself. So maybe I'll show you real quick. Radix sort, right? Okay, so you can see that we declare a end which is basically the max, which if you see here, whenever we sort it, like we pass in the wait hold up yeah, we pass in the radix sort, we pass in the end, so that is the max. Okay, so we go now the end within the, what do we say, the end, and the and at this position there are zeros. Okay, so you have to keep that in mind that there are all zeros, and in this position this end that is within the file becomes source pointer position, which is 1 plus the end itself, which is 3. So this is 4. So now when we go on to sort, we are sorting from this up to 1, 2, 3 and 4, right? Maybe end is here, so we go max. Okay, so we set, yeah, we are sorting up to this end, and in the file we always go less than end, right? SP should be less than end, yeah. Okay, so we are sorting for, we're sorting up till here, right? So when we replace, then we replace this key 1, then this is the max 32, right, then 3, and then we have 0. So our boundary is here. So obviously what is going to happen, what will happen is that this 0 will shift here and this will come here. So 1, 0, 3, and max 32. So that's why when I try to delete, right, when we insert it's okay, but when we try to delete something, this happens, right? So way to fix it would be to limit the end up to here, which I can do is finding, I can do easily here is by limiting find min, right? This is the function which I use, find min hit in middle, or I can go if middle is less than equal to 0, then we return 0, else we return middle minus 1, right? So by this change, what I have done is if I rerun the let me rerun it real quick. Okay, clear, and we make. Then I clearly have this 1, 1, 2, 3, 1 and 3, right? So if I go up here, let's see, where have I defined a function to print max? Instead of max we go end, and then we make clean, we make it again, and this time we added 3, then we added 2, right, then deleted 3, and everything's fine. Great. So but this poses another problem, is that in the add function, right, in the add function I should check right, here we have map content add plus plus. Okay, it should really check if this element exists. Okay, so and my function find min should return key, right, this key. Okay, return this, else return hi. Okay, hi, right. So add function, okay, so that's taken care of. So in the find function I should first, it should find the element if they are trying to add function, right, before we do. Okay, even though the element we declare here is static, however, since we know that we cannot refer to the local variable outside of the function, then how can we add this element? Okay, answer. If the element is static in nature within the function, we are not concerned with actually adding the element itself, but the value that it holds. As the memory for the element is already allocated within the map, we can simply override the struct at the new position with right. Okay. So I have an error, right? Okay, so before adding the key into the map, we must check if it already exists. So we can do that simply by RME element exists equals I map and the key. So we go radix map underscore find m is capital, yep, m is capital. Okay, we go radix map underscore find pass in the map and the key. Then check, we say exists should be null. If it is not null, then we say error, the key, error, key already exists, right? Okay, so let me try this in display map. Okay, I don't need display map again and again. Maybe let's say radix. Okay, how about I just duplicate this and we go first clear yeah, all test passed, all test passed. Oh, sorry, my bad. If it comes out, it should not be negative. Okay, so we say if it is not null, then we have a problem, right? If it is not null, then we have a problem, right? So we get a bunch of error, key already exists, key already exists. Failed, cannot find element. Why did it give it to me 5 times? Key already exists. Okay, we go to map, right? Radix map, go to add, then this says -1. Do we check for -1? Okay, radix map. Test find min. Yep. Key already exists, key already exists, key already exists, key already exists. And then add, we get cannot find element. 126, 181, 26. Key 2 cannot find element. Wow. Okay. So we say check error, key already exists. Then it should return a -1. Right? It shouldn't add it. Find map comma key. Check key already exists. Right? I don't get it. Why is it called? Why is it being don't I have an executable anymore? Oh. Okay. Oh, sorry, I didn't have to. My bad. GDP tests. Okay, give me a backtrace. There is no backtrace, no stake, no stack. Okay, but he already exists. Why does this comes 4 times? I go here, right? 1 at 181. This is 126. This is 181. You're right, 181. Check. Simple binary search. We return and middle If it is not null, we say key already exists, and it should simply jump to. We don't do that, we don't sort it, we simply return -1. Okay, I don't get why oh, that's why, my bad man. I should put mu assert Eric's map should not be equal to -1 error key already exists. Yep, there we go. Okay. Let's go copy and paste here. Then copy and paste here. Copy and paste here. Oh. Then copy and paste here. Copy and paste here, and then copy and paste here. Okay, so clear, make clean W, and then we make, and error key already exists. Then it shows key already. Oh, okay, hold up. I create an empty map. I 115 key already exists. It should return a null. How can it return a key already exists? Bro, are you out of your mind? There's definitely something wrong here. See, radix map at 115 goes at 115. I mean here. Okay, so I'm passing the key, right? Key. I'm passing the key, not the value. If it's searching the value to find, we get this low high key equals this, and this is the key I pass. How can it already exist when it has not been added to the map? Yeah, before adding the key into the map, we must check if it already exists. So it will go in and it won't find found the key. Well, and right? Does it print? Okay, release map dot c182. C182. Yeah, queue already exists. That means I'm doing something wrong. RMEM element equals this. Oh, is it because um, the data? Let me see how does it get. You initialize it with calc, right? Calc. So it by default it should be 0. By default it should be okay. Doesn't matter. I will base it on the size. Exist. Okay. If map end is greater than 0, then I want to check this condition. Let's try this. 116 key already exists. Man, oh man, this is some serious bug. Where am I supposed to? 116 it said 1. Index 1, huh? This okay, 0 to 0, right? Says 0. How can it even keys data if less than, middle then, right? Okay, then give me a okay, not break, clear. That's right, I do have a XCDP. Okay, I want a break. I think I define a and a line number. Let me CDB help, man. Okay, how do I add a breakpoint? It should be right here. Well, CD I think help, yes. Okay, user defined aliases, breakpoints, list of class commands. Okay, help followed by the class name for a list in commands. Okay, so I want help and breakpoints. Sorry, help and breakpoints. Okay, so we go BR, set a breakpoint at a specific location. What is the, let's say, set catch exception, catch execute, catch fork, handless load, rethrow signals, call, throw. Okay, commands, set commands to be executed, delete breakpoints, delete display, delete. Okay. So I go die for more. Okay, that's a lot. Okay, BR. Breakpoint address now. BR. So let me go clear. Then I might have this, and I want to add a breakpoint. What happened? I typed the wrong letter, I suppose. Breakpoint N1, breakpoint N2, no, PR. PR. What is happening? Okay, clearly, so there's something wrong, right? There is something wrong with this function find, because it is finding all sorts of stuff. Oh, is it because make random and radix map underscore create 10? No, it cannot be. Map 1, right? Let me, okay, if it even finds it, right, then let me log info exists. Okay, it shows me RMA elements, so I'll go to data and dot key. Exists dot data dot key. Okay, it is a pointer, so let's make clean W, then let's make it, and I want, okay, now see, because it did not exist, right? Okay, let me just print exist, right? It is 0, right? But still, okay, I'm getting a null. Check should not be null, right? Is a null. I say this condition should be true. If it is not, then we okay, right? Because I think my logic was wrong there. So I go clean and make, and we get 0 0 0 0. If say at 121. At 121. Ah, nice. Key already exists. Right, nice. It exists and it fails. Right. Okay. So okay, coexisting also also nothing. Let's take this out of here. Let's put it here. Then let me check if it still gives me the same error, right? Key already exists. Failed error, key already exists. Right. So it is my run. If I say that this should be null. This should be null. Right. Okay. Let's say 4. Okay. Everything's great. 0 0 1. Now this is not right, because in the display map, where is display map? Data.key. I display the keys. It does not display me the key. And index and this, here are index and these getting printed from index. Okay, let me say printf. There we go. Okay. Delete. Right. Okay. So again, this is not right. Okay, I fix one thing, I mess up another. Okay, so we have exist should be null, and we directly throw a -1. Sort map x right up delete. If middle is less than equal to 0, if middle is less than equal to 0, we return a 0, else we return middle -1. Else if it is not less than and if it is not greater than, then it is equal to. Return high less than, if high less than 0, we return 0, else we return high. High less than equal to 0, return 0, else we return middle -1. Right, okay. So this is not right. So let me display the map up to here. Okay, so we get 1 2 0 0, which I don't understand. Why is it 0 and 0? User radix map. What happened over here? I get 1, but I कर दो let's forget about deleting stuff. One, two, three, 0. What happened to 4? Okay, let's index 0, index 0, index 0. then I get index 3. Okay, for first I understand this right, middle less than 0, 1 2 3 0. Not yeah, see, okay. Find the position of the element that comes just before the position of the new element, right? So for the first two I understand. Let's map, yeah. Okay, so I have 3. Okay, yeah, no, that is correct. But for 4 I get a 3, which is incorrect, right? Which is incorrect, definitely incorrect. I shouldn't get an index 3. That's why I'm getting, okay, because I added 3, so get, see, if I display the map right here, see, I have 1 and 3, then I have 1 3 and 0. If I display the whole map, here we have 4. Okay, so it clearly did something wrong. 1 and 3, I have 1 2 3, and then I have a 4 over here. So I have, so it seriously have some fault. While how did it end up with 3? Okay, index 3 plus source plus that, index 3 plus end 0 1 2 3. See, this position that it found is incorrect, because the index should be 0 1 2. In this condition, let me, okay, so let me go open with paint. Okay. Yeah, okay, so let me see, I have 1 2 3 and then nothing over here. Okay, so we go middle. Okay, this is low, this is high, right? This will contain the position of the key smaller than the one we set. Also, I have to handle the case if we have add an element which is smaller than the element at 0, the index and high would become less than 0, which is invalid. Hence, if so is the case, we simply return 0. Okay, calculate the middle and get the middle corresponding to it. Find min. Right. Okay. See, I've calculated if I want to insert 6 here, right? So binary search, we go 0.42, limit equal to 6. No, update low, so we go middle. It is 6 is greater, so we increment the middle to 7, and then we have 3. Is it? No, it is less than, so we decrement the high. Okay, so let me try here. What happened here? What happened in this case, right? What happened in this case? is, let's say, pehla middle equals 0 plus 2 by 2, that is equals to 1. So then we check, I want to add 4, right? So we check a of 1 is not equal to 4. In fact, this is greater, so we increment the high, right? Now, so we increment the low. Now low is mid plus 1. So low is, see, this is 0, 1 and 2. Now low is 2. So low is 2. Then we go 2 plus 2 by 2 is equals to 2. So a of 2 should be, a of 2 is greater than, is a of 2, it is not equal to 4. So 3 is less than 4. So 4 is still greater than 3. So we go, low gets incremented to again mid plus 1. So now low is 3, 2 plus 1 is 3, and clearly low is greater than h. So this condition should have failed and I should have got a 2, but instead I get a 3, right? Instead I get a 3, which is wrong. My logic is right, then why am I getting the wrong answer? Right, because up to here, see 1, 2, 3, perfect. Okay, what if I add 4 and then 2? Okay, what happens then? So it is substituted. Okay, so something wrong is happening. 1, 2, 3 and 4, but now I have a 0, right? So I feel like it is incrementing it is incrementing and let's do it old school. Check that end, yeah, okay. Map of end is element. Oh, okay. So no, this is correct, but I have to find the index before it increases the end, I think. So map and then key, and then we put the element in. I feel like that is a problem. Okay, it made it even worse. Okay, 100023. Man. Okay, but at least the index should be right. Index is 1, 1. For 2 I understand 1, but for adding 4, okay, for 4 it should not, okay, minus, but when I'm more confused. right? Low should be less than equal to high. This has made me more confused. I don't understand this, man. I know clearly. Okay, see. What is this? Okay, I was trying to do something, but oh, this is part of nodes. So my logic is right. Go high equals end minus 1, since end stores a value just past the last element, right? So end minus 1. Source, right? I have a source pointer, and in the source, okay, so I first provide the source, which turns out to be correct, right? For the right, then we go with temp, and final answer is in the source. See, source, right? So end sp equals source plus max, right? And max is end, and this is the source is the pointer to the value, right? Pass in the source. What is source exactly? End equals source plus max. Predict sort. I get the index, right? I pass the index from here on up to the end, right? Should be less than end plus max. Okay, but I don't get this, man. First we compute the index of the element with just a key. The key just smaller than the element we want to add. And increment and resort the order of the elements. Okay, so it is finding so there is something wrong with this thing here, right? 32. Okay, so while let me add a breakpoint at this position 120. Okay, so we go GDB test start C breakpoint. We go. What's this? redxmap.c and line number 120. redxmap.c line number 120. Breakpoint added. So we go run. Hide break. Okay. Find men. Right. Key optimized out. I don't know. Source file is more recent than executable. Ooh. Then this is in W and then make. Yeah, all tests didn't pass, my buddy. It didn't. Okay. So we go with is there something wrong with the sorting or with the function that I've implemented? Right. The function that I have implemented. Okay. So we go ahead. Then breakpoint add redxmap.c 120. Run. Okay. Return hi. So print flow optimized out. Print high is -1. Low optimized out. Okay, because it didn't even needed it. Okay, then print middle in the current context. Oh, and straight up hit. Okay. So continue. Then we again hit key 2 and let's print low. Print high is 0. And then print middle nowhere in the current context. Okay, so it clearly returns to this position. Okay, continue. That is all. I should okay, 120. Okay, so usually just hit this block within the block, outside the block. It don't just continue it, right? Okay, let me try. We are redxmap.c 98. So, and tell redxmap.c 120. Okay, so run. Okay, right. So 98. Okay, so it only hits these, right? Okay, so I should 101. It should be 101. Okay. Let's quit. Yes. Okay. Let me run this again. I want to hit a breakpoint at 101. redxmap.c 101. Run. Okay, right. Okay, now I can just end LH is equals to 23. Right, it doesn't really matter. It just needs make clean W, and then we make it again, and then I pass it through GTP, and I put a break at 120. Predix map dot C 120. Run. So print high, print low. Oh, optimized out. Okay, right. Continue. Print, dude. Okay, I've added 3, so it didn't even check it. Then I've added 1, 0 minus 1. Okay, right. Print low, optimized out. Print high, high is 0. Because this minus this, right? Okay. Continue. What about that, man? Fuck this shit. Okay. Okay, 101. Maybe I can try. Let me delete the breakpoint at predixmap.c 120, and if I run, okay, so 120. Didn't I delete that back? Fuck this shit. Okay, so we go again, and this time I add 101. Okay, C 101. Okay, 1. Right, so print low. Low is 0 here. Print high. High is 0 here. Though I don't believe it. Let's print the key here. Key is 3. Okay, Redux map key is 3, and let me print map end. End is 1. By default, is it 1? When the map gets created, it's the end 1. I believe end is 0, right? Okay, so I have. Okay, because when we add, we already increment it, right? Okay. Right. Then run. The program being started already. No. I mean continue. Okay, so now key is 1. Let's say index 0. Right. Key is 1. Let's say print low, print high. High is 1. Okay, so end has been incremented to 2, right? Print map end is it's 2, and let's try and print temp underscore key. We don't need that. Okay, so continue. Okay, now key is 4. Now key is 4. Okay, so now key is 4. So let's print temp underscore key. Okay, we don't even need the key. Keyless. Nice. Okay. So I'm not comparing with the key. Why is it just optimizing out the key? Right. I say if this less than a key, and if it is greater than key. Okay. So let's print low. Let's print high. High is to that. Yeah, that makes sense. Okay, and if I continue, we hit it again. Okay, now print low. Low is 2. As that I have Right, so low is 2 here. Okay, right, so it was supposed to be 2, which is correct, and low should also, high should else be 2, and middle I think is also 2. Okay, so we are okay then. Okay, so index is 2, which is correct this time. Correct this time. Now index is 2, so it should have sorted. Let me try print map and is 4. That is paint. Okay, here. So 0, 1, 2 at okay 1, 3. Wait, how many elements? Let me go map contents, map contents of index, index index 1, then data dot key, sorry, print 3. Okay, so that's 0, 1, and at 2 I have 0. When index is 2, how come I get a 0 here? Okay, at 3 I have a 2, but I didn't even add a 2 yet. 0 I have a 1, right. Yeah, okay, so